Alright, so for our next assignment, the room that we have is the OSI model, and OSI model stands for Open Systems Interconnection Model. So the first question that this one asks is, what does OSI and OSI model stand for? There's the answer. The second question was, how many layers and digits does the OSI model have? Right here you can see there's 7. So 7 right there. Boom, that's the correct answer. And then what is the key term for when pieces of information gets added to data? That's called encapsulation. You can find the answer for that. I think that was towards the bottom here. Yeah, so we only need to understand that this process is called encapsulation, which is every individual layer that data travels through. Specific processes take place and pieces of information are added to this data, which is what we'll come to discuss in the upcoming task within this room. And just understand that process is encapsulation. First layer is the physical, so you're going to think, hardware. This is the easiest one to grasp. So what is the name of this layer? Physical. What is the name of the numbering system that is both zeros and O's? And that would be the binary language. And you can see that right here. Devices use signals to transfer data between each other in a binary numbering system. Binary meaning 2. What is the name of the cables that are used to connect devices? Ethernet cables. Think about, like when you connect to the internet with Ethernet cables connecting multiple devices. And that answer right here, connecting devices, such as in the picture, Ethernet cables. Let's move on. Second layer, data link. Data link focuses on physical addressing of the transmission. So what is this layer? It's data link. And then what is the name of a piece of hardware that all networked devices come with? And that's a NIC. They all come with a network interface card. And it kind of goes on like from the last room we were talking about the first and last names of a computer, or the names and fingerprints. This would be like the fingerprint right here. The third layer is network. And then will packets take the most optimal route across a network? Yes, they will. And that is on here. It shows that what path is the shortest. It's showing going through. Right here is the easiest way to put it. Simply determines the most optimal path, which chunks of data should be sent. What does the acronym OSPF stand for? Open Shortest Path First. Answer to that one was found here. Briefly, these protocols include Open Shortest Path First, which kind of piggybacks on how they take the fastest route. And then what does RIP stand for? RIP was Routing Information Protocol. That was found here. And then the last one, what type of addresses are dealt with in this layer? And it's IP addresses. So at this layer, everything's dealt with via IP addresses, such as this one. There we go. Cool. Level 4 transport. Let's see, level 4. What is the name of this layer? Transport. What does TCP stand for? We've gone over this in a previous room. Transmission control protocol. I think it does also mention that up here at the top. And then the second one, what is UDP? What does UDP stand for? User Diagram Protocol. That's on the second level here. And what protocol guarantees the accuracy of data? TCP, because it makes sure, it's like with the handshake, it makes sure that connections are there and everything's being uploaded, and the second device is getting it, everyone's getting the information. And then what protocol doesn't care? It's UDP. What protocol would an application such as an email client use? It's TCP, because you want to make sure they get all the information. What protocol would an application that download files? Also TCP. You want to make sure you get all of the file. And then what protocol would an application that streams video use? It's UDP, because you can have times where it doesn't have everything and it can still continue. You can keep it going. I like to think of that, and I could be wrong, but it's like, if like the video of something goes out, you can still listen to the audio. Let's see, let's go here. Layer 5 is session. The first answer, session. What is the technical term for when a connection is successfully established? And it is a session. Doing this one, I was a little confused because I didn't think the answer was the name of the layer, but turns out it was. Let's see, go here. 6, presentation. What is the main purpose of this layer? What is the main purpose that this layer acts as? And it says translator is the main purpose of what this asks for. So the OS layer, which is standardization, starts to take place because software developers can develop any software, such as email cliently. The data still needs to be handled in the same way, no matter how the software works. I think this one's kind of more like everything, just keeping everything together. So this layer acts as a translator for data and from the application layer. This receiving computer will also understand data sent to the computer in one format destined for another format. For example, when you send an email, the other user may have another email client, but the contents of the email will still need to display the same. Okay, yeah, it's just so everyone can kind of operate on the same thing. Everything can be found at the same time. You don't have like one company saying you can only use our emails to view emails from people with a different email. That's kind of how I think of it. Okay. Layer 7, application. What is the technical term that is given to the name of the software that users interact with? Graphical user interface. That's going to be things like, this website right here. It has graphics for the user, and it's an interface of something that we can interact with. So that would be also right here. That's where it shows that answer. It's for users to interact with data sent or received in a nice looking way. Alright, can you escape the dungeon? This is just a game on the side, going through the layers, and you just got to get through pretty much. If you pull this up, it's just physical, data link, network, transport, session, presentation, application. That's what the game goes over. And then the last one is just continuing on. And that is the end of OSI model. Cool.